Hi everyone. So I'm Marnie Shaw. I'm from the still fairly new Battery Storage and Grid Integration program at the ANU in Canberra. It's our new logo. So as we know, we're moving towards energy model where electricity is being increasingly produced and consumed and stored locally. So we have the emergence of the prosumer, who not only consumes electricity but produces electricity. So where we need to move now is to build new energy models that not only accommodate the prosumer but really capitalise on the prosumer. So we have an opportunity now to build these new energy models that are not only cheaper and more reliable but more fair. So one of the ideas that we're looking at for new and innovative models of energy delivery is this idea of community energy models. So what that means is where the load and the storage and the generation are not necessarily behind a single meter. So for instance, shared battery or shared solar PV. So this, from our perspective, has both social motivation and also technical motivation. So socially, it could give an opportunity for more of those Australians who can't access renewables at the moment to access renewables. So those 1/3 of Australians who don't own roof. And the decreased costs that are associated with these models may make access to renewables more fair. And there's a significant element here of community engagement and community benefit involved in this kind of project. So we heard yesterday a really great example from Rex, who was talking about the community energy model on the Isle of Egg, which was really interesting and inspiring. Can you advance one slide, please? Thank you. So from a technical perspective, there could be some real advantages here. So one is a smooth load profile on the grid. So it could have advantages for the grid function as a whole. So this is work that's done by a postdoc in our group, Chaturika Mediwat, where she's looked at the idea of a shared battery and how that would impact the aggregate load on the grid. So here's the blue line is showing the aggregate load with the shared battery, and you can see it's a smoother load profile, so you don't get these peaks that can be problematic for operating the grid. One thing we're really interested in looking at is whether these models will increase the hosting capacity. So that's basically how much renewable energy, so how much PV we can put into a certain neighbourhood or area of the grid. And from our modelling so far, we see that there could be a big increase in hosting capacity that we can get from using these models. There's also other potential advantages. One is the increased ability to supply energy to the grid during overload or an adverse event. And there may be opportunities for these models to more easily participate in other markets, like wholesale and FCAS markets. So has this been done already, these community energy models? And the answer is yes. In Australia, there have been a few trial projects already. One is the Stucco project, which is about 2 kilometres from here. This is like a student cooperative housing, and they now have shared solar on the roof and shared batteries in the basement. And this Stucco project was designed and project managed by an engineer in our group, Bjorn Sternberg, and is operating very successfully. And here's a photo of a shared battery system that's gone into a new residential housing like estate. And this is a partnership between Synergy and Western Power in WA. So basically what we're seeing in Australia is kind of a flurry, a huge increase in interest in these new community energy models, and driven by consumers and community groups, which is really exciting, bringing lots of new ideas to market and increasingly attracting the attention of network operators. So at the ANU in our group, what we want to do is build tools for these groups to use to look at both the business and economic side, but also the technical modelling of these models and how their operation would impact the grid. So this project that we're looking at has been just funded by ARENA. That was announced just last week. And we're working in partnership with ECA as well. So I just wanted to give you a taster of how this, so what we're building is this community energy model calculator and how it would work. So basically we input data. The data that we input will be different depending on the question that we ask in the end. The calculator is looking at the operation and the model, including the scheduling of the battery under particular optimization constraints, and also possibly power flow modelling, depending on what you're looking at. And then we output the value. So value here is written like this because value means different things for different people. So it's different for the customer, it's different for the retailers, it's different for the distribution networks. So it could be an economic value, it could be this hosting capacity value, which is emerging as a really important measure that we need to know about. Load and power calculations, and potentially also fairness calculation, which could be really interesting in light of all the social equity issues that we've been discussing. So I just wanted to show you an example of sort of work that we're doing. So we're using the next gen data, which is collected in the ACT. This is it's brand new data. I think we might be the first to use it. And it's very rich data. It's 5-minute resolution load PV battery data. So not many data sets around like that. And as well as some custom information and more power information. And it will eventually be available for up to 5,000 people in the ACT. So at the moment we have about 700 customers. So here's an example of a typical winter day in the ACT. And this is our ACT duck curve. So we put that data in, crunch it through a calculator. Here our model is a shared battery. So how would a shared battery impact the peak network load differently to if we have everyone having their own batteries? So here's our little value measure that we get out, which is peak network load. And what we see, this is very preliminary results, but just to show you an example of what we're looking at, is that with a shared battery, you get almost half a reduction in the peak network load compared to if everyone has their own battery. So this is an example of how we're using currently available data to explore innovative energy delivery models. So, thank you.